We stopped on the dealing with the tower shortage or shortages through the whole globe, and as you can see, this is a very serious problem. Uh, One third of the world's current population lives in the countries where tower supplies is not present, and they don't have the technologies to improve that situation. So mostly, as I said, in the Tibet area, Mongolia, North Africa, and some others, Australia. Australia is really majority of its land is desert. So those areas, but they have the technology to manage the shortages. Somebody will tell me how to manage the shortages. You will see those developed countries such as Australia. They do have what? Desalination of oceans. It's an island, a huge island. It's a continent, but it looks like an island because all over ocean, all over the places. So in order to get this around this 90% of or more of the Australia land is desert. To get around this, they use a lot of heavy plants. Desalination means they evaporate the tower from the ocean, keeping the salt, magnesium, and calcium nitrate inside. Now, they can even take the salt with it, and the salt is a very good fertilizer, can be used. The nitrate is a very good fertilizer source for the plants, but they are interested in the tower amount. So the problem is with those type of plants, desalination plants are very expensive, and they have a major problem. What's the major problem you think about? You have salty tower, and you want to get just the H2O, the tower out. So you face a problem. What's the problem you think you can face? The major problem you can face is filters, because this is the same thing. You are filtration. This is a process called filtration. So those filters are very expensive, and to reprocess them and keep them, reuse them again, recycle them again, that's very expensive. So desalination oceans are very expensive ventures. So it's not really cheap. It's not really cheap. So that's one of the major problems of this desalination. But it's very efficient, though. You get a lot of fresh tower without any, very pure and very clean. We are living in age of thirst. That's really true. And whenever there are droughts, it will affect not only the status of the status of living in that area, but it affects everything in that area. The food that place will have shortage in food, will have shortage in health, a lot of stuff, because as I said, the tower, the H2O is a source beside oxygen, and those are the source of living inside of living properties in our globe. So in the United States, first drought happened in 1930, so a long time ago. But on and off we get droughts, but it's not permanent. It's just for a couple of months, and then you get a rainfall, replace whatever was missing. Groundwater supplies are being depleted, and this is one of the major problems. The tower seeping to the ground is a very slow process. It takes years to seep into the ground, but if you dig wells to get this tower, by the time you dig the whole well, you empty the whole well, and it takes years, maybe 20, 30 years to fill this aquifer. So it's not that quick process. Seeping, it takes time. And seeping, it has to be naturally slow. It can be very fast. The seeping rate of a tower into the ground is very slow process. That's the reason you have air bubbles inside the soil to maintain the pressure. If the tabor is coming very fast, you'll fracture the soil itself, and even you'll fracture the aquifer. So therefore, it's really difficult. So we are digging a lot of wells, and that's happening in North Africa, Tibet, Mongolia. They dig a lot of wells, and then after a while, they see those wells are really dry. They are abandoned. There's no tabors inside. They might come after 50, 60 years, 100 years, they can get some tabor inside the same well. So it takes time. The seeping rate of tabor inside into the ground is a very slow process. But you can dig a well and have a big pump. You can pump very quick. You can pump in a couple of weeks or months the whole aquifer. But to get this replaced, this tabor taken out, it takes years, 50 years, 100 years for a well to be recovered. It's not one day or 1 month or 1 year. It takes years to do so because the seeping rate is very slow. And that's one of we are very fortunate to have slow seeping. If you have a higher rate of seeping of tabor inside the ground, the pressure of the seeping rate will just fracture the soil, fracture everything there, will destroy everything, and you will end up this tabor will run just out into the ocean, so not be held or not be held in that specific area. Diversion project redistribute tabor. That's really true, but with this diversion, you have a big problem. You have to build huge dams and canals, and every time you build the dam or canal, you have to really bear in your mind you have created an area, they call it earthquake zone. So anytime we build a dam, huge dam, especially huge, not small tiny one, but a huge dam that really has a large amount of tabor volume, there is a source of what? Somebody will tell me why? So if you have an animal and you put a lot of weight on that animal, can this animal move? No, it's too much weight on the back of that animal. Are you following me here? And this is the same thinking about those dams. You put a lot of weight. The weight of the tabor is the mass, correct, multiplied by its density. So that's weight on the floor on the ground. Put a lot of pressure on what? On the layer from the soil down. So the huge amount you put, so that area underneath that holding this tabor will come one day, will fracture, and then you get the earthquake. So anytime you have dams, I mean, when I say dams, or those are larger ones, not the small ones. And that's one of the China have the biggest. You heard about the China. They have a huge, huge area of combined dams. But the problem is they will face in the future. That's an earthquake. You are really producing artificially an earthquake. Will come. You'll hear that dam, the huge dam in the whole universe now, is in China. It's still built. Now over 10 or 15 years, they're still not finishing it. Huge. You can Google the picture of it. It's really huge. They took all the villages, all the cities out. They displaced the people, and then gathered all those couple of rivers, dumped their tabor inside. However, they will find the fact that this area will be artificially manufacturing earthquakes. So that's we have always to think about this, because you put a lot of pressure on the layers of the ground, and that will have a lot of rupture in the layers of the ground underneath the dam itself. questions of justice often surround dam project. That's the same thing is what's happening in this big project of a big dam in they built in China. They have displaced people. They have moved all the villages around, even small cities out. So thousands and thousands, maybe millions of people in China are displaced by building this huge dam. So, well, that's a question. If this justice or not, I have no idea. I can't answer this, but that's not fair for the people being displaced and living for thousands of years with their great grandfathers and mothers there, and you are now replacing them with the huge project. That huge project, 100%. One day you'll hear an earthquake. That's a normal because you put a lot of weight on that area, on the ground, on that area. The same thing you have an animal. You put a lot of weight on an animal. The animal will not move, will break down, and maybe just collapse in front of you because the weight on the back of that animal is huge. And it's the same thing with the ground, the earth ground. If you put certain localized pressure on it, it will fracture, and that's earthquake. So anyway, displacing those people for those villages and small towns, is this correct? I can't answer this question, but from my personal stuff, it's not correct. It's not correct to displace people just because you want to build a huge stuff. There are other technologies you can use. Some of it I just mentioned, desalination of oceans. China has an outlet to the ocean. And therefore, if they can build a lot of desalination and make it cheaper to recycle those filters of this desalination plants, they will be easier than displacing millions of people out of their houses and homes and villages and towns. So, and here they as you see here, it's mentioned here, the same thing I told you here. This is always you have to count for. This is a must, whether like it or we don't like it. I saw through the years those dams in some areas they collapsed, earthquake, because there's too much load on the ground, on the surface of the ground, and it's the same like a poor animal. You put the higher huge load on its back, it will break down and collapse. And the same thing with the ground. I mean, and you fracture the soil, it goes all the way the pressure into the deep inside the ground, and that's because the layers of the ground is splitting, and this you get earthquake, and that's what it says here. So most of the time, I'll say 90% might not happen per day, but it takes time. It takes time. This pressure, you are putting pressure per day on this localized area, and the whole thing will collapse, and you get trigger of huge earthquakes. So would you fight for Tabor? Well, the answer is yes. You can see all over the place. The Mongolian tribes, the Kenya tribes, the Tibet's Mongolian. Tibet belongs to China, but the Mongolia is up north. But those tribes are fighting Kenyan, Sudanian. There's a lot of people, nomads, mostly they are living, they don't have houses. They move where's the Tabor there. So they are not settling down in one place. They are moving around to wherever is Tabor there. So they fight. They fight. If 2-3 tribes coming in, or 3 groups of people will come in, and whoever will be the strongest will take over this source of Tabor. So yes, there is a fight. Yes, people are fighting. Not me, but said, would you fight? The answer is yes, because that's our sustenance. Without it, we will be dead. We'll be dead. I mean, we can stay for weeks without food, but we cannot stay for a couple of days without Tabor. It's impossible. It's almost impossible. You'll be dehydrated to the to the point that you cannot even talk or walk or do any process. I mean, your muscle will not even move at all. So you'll be really. Well, the first thing you do in the emergency room, what you do? You give the patient what?
IV.
IV. What's inside IV? What's the purpose of IV? You want to hydrate that patient. You want to put a lot of minerals and a lot of tap water inside that body so that body will maintain a good temperature, maintain a good nutrition of the electrolytes. So that's you do first. That's you do. And the same thing is with us, with the people that are on the desert, like as I said, Mongolian. They are really fighting tribes. Darfur in Sudan, Kenya. There are a couple of places they fight on this source of tabar. I mean, this is death or life. This matter of death or life. So that's it. It comes to this point. And you'll do the same thing. I mean, tabar is very essential for our life. Water conservation and management. This is one of the methods we can really managing the amount of the tabar going into the soil. Okay, so by planting a lot of good plants around the watershed, because the watershed is just the water flow goes to the main rivers. So if you are managing this area, you can control how much of tabar will be dumped and how much you can keep. And you can build a lot of. You can plant a lot of good plants that really will help you to keep this ground tabar there. So. This management is very, very important, especially in the countries they don't have that good technologies. This watershed is a very, very simple and natural processes. You don't have to spend a lot of money on it. Just divert the flow of the rain tabar coming out, divert of it through the soil, through the area, so they can manage how much will go to the rivers, how much will be kept inside the ground. So you don't have to do that much of technology there, and then you can plant a lot of special plants that's really resisting any evaporation of the H2O. It's protecting the tabar from the sun, from the heat. So it makes the temperature mild so that the tabar will stay for a longer time. Everyone can help conserve tabar. That's really true. So we could probably save as much as half or more sometimes of the domestic purposes of tabar in the domestic purposes. So here, give you an example here. Take shorter showers. You have to fix the leaks of tabar inside your house, your home. Be considerate when you wash your cars, not spoiling that much of tabar. When you clean dishes, when you clean your clothes, all those stuff here will help to reduce amount of tabar going to the sewer, and then from the sewer to the river or to the ocean. I'm saying this because in developed countries they do have all the sewers. Tabar will go back and will be treated chemically, will be treated naturally first, and then chemically they go to special plants, will absorb any particulate or any large one, or they put some filters and then it go in, and then it will be treated chemically for any viruses, bacteria, any stuff. And you will see yourself that the tabar coming from the county is as good or even better than the one that's coming in the bottles. I mentioned that before, correct? Mm-hmm. And in this PowerPoint, he agreed with me He said there's a lot of people think the tap water inside the bottles are healthier and purer and whatever, but that's not really true. Even the author agrees with me. But we did the experiment though. He got whatever from the literature, his knowledge from the literature, but we did, and we came up the same thing. There's no difference. Just you can make your own company, have those plastic bottles, fill them with the county tap water and sell them. Here we are. So here you have a business by yourself. So water conserving appliances such as low volume shower heads, efficient dishwashers can reduce the consumption of the tap water. What can you do? Well, it says here just, I'm not going through this, but you can read it. You have don't flush every time you use the toilet. Take shorter showers instead of longer one. And they give you all the tricks here. Put a break inside the full water bottle in your toilet tank to reduce the volume of water in each flush. Use tap water conserving appliances, low flow showers, low flush toilets, and aerated faucets. And all those are just to minimize the amount of waste tap water dumped inside the sewer system, and then from there to the water treatment in the developed countries. In non-developed countries, this all the sewer will end up in the rivers and lakes and ponds. You will see in Africa especially, and in Mongolia. Mongolia, they don't have tap water, but in Africa, most of the West African countries, they have a lot of rivers, lakes, ponds contamination, because there are twofold problems. One is there are no regulations. I mean, the leadership of the country has no regulations intact. So there is no law. I mean, so the companies will come and dump everything inside those rivers and lakes and ponds. And then second reason is the people, not even the industry, but the people themselves. They have no way to get rid of those. They just dump the whole thing through the sewer system to the rivers and ponds. So efficiency is reducing tap water use in many areas. So we have our populations increase about over 400 million now, 400 something, 400 maybe 30 or 50. But still, if you look 30, 40 years ago, you will see the consumption now of the amount of the sewer or sewer tap water is so controlled that we have the smallest amount, and that's reflecting in the bills. So if you use too much of the tap water, you will be. If you look at your bill, you are billed for the tap water you are using, cooking and whatever, washing, and the tap water coming from the bathroom. Correct, from the bathroom. So you are billed for two. As I said, they put a lot of whenever you have those water treatment plants, you can go and visit. So we worked on some contamination remover chemicals. So they cost a lot of money, those treatment plants, believe it or not, and those coming from the taxpayer money. So that's the reason, if you reduce the amount of tap water wasted tap water or contaminated tap water inside those treatment plants, you'll save the city or the county a lot of money. To maintain those treatment plants cost a lot of money, believe it or not. It costs a lot of money because you're not only fighting the contamination, you are fighting every bacteria you can imagine or active virus you can imagine might be dumped or might be just coming because of this waste. It's good for those viruses. They grow very well. So you have to fight the bacteria, and it has bio and chemical and biochemical waste inside those, and they have to clean it up, and cleaning it up costs a lot of money. Pricing may affect our tap water usage. Tap water from Stressed Lake mead costs 33 cents. That's in Las Vegas. They have a very good area. So that area near lake costs just only 33 cents. The treatment there, water treatment. I think 30 cents per meter. So in Atlanta, it costs about $3. So you can see that the difference in those. As I said, it's very expensive to run those treatment plants. And I think a county has one here. I think DeKalb County has one. Yeah, I think each county has one. So to deal with this treatment of waste, contaminated tap water. Any water pollutants. What do we mean by water pollutants? Well, they can the pollution can, as I said, can be from the biological pollutants or chemical pollutants. Biological, you get all these viruses, you can name it, bacteria can grow and can resist any of those chemicals. So you have to be careful what type of chemicals you are using. Most of those chemicals are using oxidizing reagent that's really breaking the cell of those bacteria in pieces. So that's what they use there. So this is the pollution of tap water is complex. It's not one way. It has too many branches. So you have biological, physical, chemical, and all those affect the tap water quality. So there are natural sources of water contamination as well. Some coming from some springs. They generate poison by themselves. So oil seeps and sedimentation from origin. So some springs, you heard about that, they develop their own amount of sulfur inside them. They have high content of sulfur at the ground. So if you get there, like you are putting yourself in an acid, it's like acidic. So those are not good. If you have a seep of this type of tap water coming from this type of springs, that will affect the tap water in that area. So yeah, some springs they for some reasons they accumulate some toxic chemicals through the years, and you cannot swim there. You cannot even drink that tap water there. It's too acidic. We are concerned about not of the natural one, and that's really true. We are looking at the man-made contamination to the tap water, so that's very important. And there is two sources of this pollution: buoyant source or non-buoyant. Buoyant source, you know the location of them. Buoyant source of contamination, I know where the pollution is coming from. Those are power points, nuclear plants, electrical power plants, nuclear plants, some industrial chemical manufacturing plants. All those, they are source of and some of manufacturing bacteria or viruses places. All those are type of buoyant sources. I know they are registered by the county. We know if we have contamination in that area. I know how many factories are working in that area, so I can target those and go investigate one by one what they have done. That's easy to control. That's very nice. But the problem is, if you have non-buoyant source, you don't know who had caused this contamination for the tap water, and that's difficult sometimes. It's very, very difficult to know from where. You can see, and that's what happened in the Decatur campus about maybe 20 something years. I'm here going 27 maybe. We started the science club there in Decatur campus about 25 years or 24 years ago in Decatur. And we were surprised that some local car mechanic dumped whatever left over of this plastic, the oil, the oil for the car. The whole plastic, they have small tiny amount. I mean, droplet or 1 milliliter or 2 milliliter left over in those bottles, and dump them in the stream near the campus. So, and you see that we have to alert the DeKalb County. They came with all their equipment to help us. And some people, they dump all tires there in that stream. Those, we call them, we don't know the source. We don't know, there were no cameras showing us who is dumping those type of chemicals inside. So that's affecting the stream tap water quality, because this stream uses, we have botanical garden there for exotic plants, one of the best in Georgia, in the South, and in the nation, I think. We have a very beautiful botanical garden, very rare plants there, and it's fed from the stream. Now, if you have pollution in the major pollution inside the stream, that will affect those plants, and it's very hard to recover. Those are very, very rare plants. You can go and visit. Somebody had visited botanical garden at Decatur campus. You did? Very nice, correct? That's a lot of deers there. Lot of deer. You have not seen. We have seen through the years. I spent about 8 years in this campus. I was in other campuses. Start here, then went here, start in Lawrenceville. It was before. Now it's Georgia. They call it Georgia Gwinnett College. Start there, then came here, then went to Decatur, then came back here. So anyway, but there's a lot of deers and a lot of snakes, by the way, over there. So that means we have a healthy environment there, because the DeKalb County comes on and off and clean up that area. That area is cleaned on and off. They come, and we were very happy that we have them in our back whenever we need a heavy machinery. So they come with the big tractors, with a lot of heavy machinery, help us to remove those tires. With some spray, some taking those oils out, flushing. So they are helping to keep, because that stream is the main source of tap water for the botanical garden. So, and we don't know who is dumping, and you cannot go and because we have no cameras until now. There are no cameras over there. So, but they come every now and then to clean up. This stream. This biological pollution, as I said, that's a lot of pathogens, a lot of viruses, a lot of bacteria can live in this wasted, contaminated tap water. So, and then cause a lot of infectious diseases, contagious diseases. So, and that's part of the pollution. Biological oxygen demand. We can use the dissolved oxygen as an index. This is use an index for tap water quality. If the dissolved DO, they call dissolved oxygen, is higher in amount, that's the tap water quality is very good. So this area is healthy. If the dissolved oxygen index is very low, this area is not habitable, is not healthy. So that's the dissolved oxygen, because as you know, that's a lot of all fish marines, all the marine life are taking oxygen, not as we are taking from the air, correct? But the marine creatures, they take the oxygen, all type of marine lives in the ocean, in the lakes, in the ponds, they take their oxygen from where? From oxygen dissolved inside tap water. So if you have less oxygen dissolved, it means somebody is using this dissolved oxygen instead of the living creatures. So it looks like whenever they are dumping anything, sometimes they dump a lot of papers, used papers, they have nothing, nowhere to dump them. They dump them in the stream. And these papers become wet, and you see they take a lot of tabor out. With this tabor, is oxygen dissolved. So that will give you the DO index will be small when you test the oxygen, because we are testing, Science Club, we were testing the dissolved oxygen, we are testing some nitrates, some stuff inside the stream. So that's alert us whenever the amount of the dissolved oxygen is less, that means something wrong. The contamination is very bad, and something is using this oxygen, and something most probably whatever they are dumping inside. Okay, so and organic materials such as sewer, paper pulp in tower increase oxygen consumption by the decomposers. So whenever you have less, it means oxygen not there, and it's used by something else. Any chemicals you put, they will take the oxygen out. Biochemical oxygen demand is the amount of dissolved oxygen consumed by aquatic microorganism, and you have chemical oxygen demand is a measure of all organic matter in the tap water. So that's some chemicals will absorb oxygen, some viruses or fungi or bacteria, they take oxygen, and those are indices are used to give us a level. But the healthy stream, a healthy river, a healthy pond, it has to show a good amount of oxygen dissolved. Otherwise, no living creature will live in those rivers or ponds or lakes. Plant nutrition and cultural eutrophication. Well, rivers and lakes that have clear tabor and low biological productivity are said to be oligotrophic, means they have less nutrition, correct? But has nothing to do with the dissolved oxygen index. That's different. But there's some area now, depending on what nutrition they have. If they have less in nutrition, we'll call them oligotrophic. If they are rich in nutritions, we call them eutrophic. So you have oligo and you have eutrophic. So two words from Latin means you have large amount of nutritions and less amount of nutritions. Just definition. So, and you need to have the area that's filled with nutrition to sustain the life of living creatures in that area. So partially enclosed seas such as Black Sea, Baltic Sea, Mediterranean Sea, all those seas are closed. They have small, tiny outlet, not that large outlet. Even we can consider the Red Sea as well. The Red Sea is the same thing. So you have those small, tiny seas. They have only one single outlet, small, tiny outlet out. Correct? Tend to be especially susceptible to the more eutrophical or eutrophication, means a lot of nutrition there. And And the idea is when you have a small outlet means this ocean does not exchange its tap water, salty tap water with the sea, with the major ocean. So if you look at this, those are closed with the small tiny outlet. A Red Sea goes to the Indian Ocean, and the Atlantic Ocean goes to the Mediterranean Sea. So you'll see those, because they exchange, the outlet is small, so they don't exchange, they don't lose their stuff to the major amount of ocean bulky tap water. So they keep nutrition there. So effluents from nearby large cities may dump untreated into the sea. Beach pollution, fish kills, and contaminated shellfish results. So anytime they dump anything inside the sea without precautions, that will or not only the sea, even in the rivers. Anytime you see a dead fish that's floating dead on a river or a pond or an ocean, that's a sign that something is dumped inside, which is very, very harmful, deadly to these creatures. Are you following me? That's always the case, always the case. Whenever you see rivers, ponds, lakes, oceans, top of them a lot of fish, dead fish, it means somebody had dumped something without legal, without legal permission. And those mostly people, they go out of, for their pocket, they don't want to spend some money to treat those contaminants they have. Rather, they just dump it inside the ocean or lakes or rivers. So, but you can see now in the developed country like here, most of the rivers and lakes, they have cameras, believe it or not. Don't think there is no camera. They are hidden cameras. Stone Mountain, they have a big lake. I am sure they have hidden cameras there. They will not allow people coming with their car and dump everything inside that lake. You can fish there, you can swim there. But if they have no way to control it, then you see you cannot fish, you cannot swim, and this whole area will be contaminated. And the Stone Mountain has a large animal population of deers, snakes, a lot of creatures are living there. So, and they are living from the tap water coming from the rain, and in that big lake. Somebody has seen that big lake in Stone Mountain? Stone Mountain has a big lake, yeah? You saw it, huge, correct? It's a huge one. And it's very important for the living creatures over there. We have deers, a lot of deers. I did not see any mountain, because we have a big hill there, a mountain. They call it mountain lions. I did not see. But there is always the rule. When I was in Colorado, whenever you have a deer, you have a mountain lion there. Because they fit the lion, or the big cat. They call it big cats. It's a cat, but huge size, like a cheetah. But it's a cat. Looks like a cat, behaves like a cat. But main food is deers in Colorado. So without having fresh, non-contaminated tap water, they will not survive. Every creature will be dead. So therefore, you will see most of the developed countries, even in Europe, even in Germany, the rivers and lakes, the public one, not the private one, the public ones, they have cameras. They want to know. I think even back in our now we are Georgia State. Before Georgia State, there were no camera. I think now they put cameras over there. They want to know who is dumping what inside that stream, which is really the main feed for tap water for the botanical garden and for the animals living over there. You have all types of raccoons, you have foxes, you have deers, you have plenty of animals living in that area. So, excessive nutrition support blooms of these deadly aquatic microorganisms like red tides. And let's speak about the extensive dead zone. Whenever there's too much of contamination is dumped inside those river, lakes, and ponds. Inorganic pollutants include metals, salts, and acids. As I said, there's a lot of metals, and one of those metals is mercury, lead. Those two major ones are dumped sometimes. But I don't believe nowadays in any developed country that's very easy or permissible. It's because all these areas of lakes and ponds, it belong to the public. They are really guarded with a lot of cameras, so anyone who will dare to do anything, he will be recorded, so he will be put the court of laws. And so heavy metals, as I said, mostly is lead and mercury, and sometimes anything near a mining area. If you have a mining area, you can see the contamination done, sometimes not on purpose, but some of the contamination of those metals extracted from the ground, some of them they seep through the system into the ground topper. So not on purpose, just because the process is you are digging out to get these metals, and some of the metals will be just flushed out, and then it end up in the aquifer, in the ground topper. So, and here just tell you this: mercury, lead, tin, cadmium, all those heavy metals, and the mining metals. Those are flushed sometimes inside with the process here into the ground topper. Organic chemicals, we talked about this. Organic chemicals that sometimes are fighting all these bugs from our crops that we'll end up having if we are overuse those pesticides, insecticides. You end up then they are part of the runoff, and sometimes they are part of your food. So that's the reason it's not good to have overusage of them. So you need just to use a minimum amount of them to kill all those bugs feeding themselves from the crop itself. So you have two principal sources of toxic organic chemicals in Tabor. They are, the first one, improper disposal of industrial and household waste. And that's, I told you now, is very controlled, because all those industrial plants, they are registered. No one is without registration. Everybody is registered there, so that's easy to track. But the problem is with the pesticides. We are using it, that's not controlled, because depending on the farm, depending on the farmers, how much they use, so they'll end up going to the Tabor ground, or seeps into the rivers and lakes and ponds, or just end up part of it inside the fruit we are eating or the veggie we are eating. So that's a major. And then I told you these pesticides are aromatic compounds. That's carcinogenic. There is no pesticide is not carcinogenic. All pesticides and insecticides, those are having this benzene ring. You see the benzene, you heard about benzene. Anytime you have pesticide, you have those cyclic and aromatic compound that's carcinogenic. There is none of this pesticide. You can't tell any chemist that those pesticides and insecticides, they are not carcinogenic. All in all, they are carcinogenic. So that's the reason you have to have more control on the usage of them, and use them really with care, and in your mind how much I have to use. And even when you buy them, they give you all instruction, and you have to follow the instruction from A to Z to adhere to this instruction, not to go away and add more or whatever. So that's always the problem with those pesticides and insecticides. Bottled water is not better, so I'm not commenting on this. We talked about this, correct? We talked about this, and this is the author idea. I did not even read before. I did not read that. I swear, I did not read that. I was surprised today when I look at the slide. I said, well, the author is agreeing on whatever we have found in the lab. So it becomes trend to drink bottled tap water. So every year, Americans buy about 28 billion bottles of tap water at the cost of $15 billion. So you see here per year. That's a lot of money, correct? Mm-hmm. And with the mistaken belief, so that's an error. That's an error in thinking. The tap water, bottled tap water is much more purer, much more healthier. That's a mistake. So he said, the author said, this is a mistake. It's a mistaken belief that it's safer than the tap water. I'm telling you, we took both bottle and the county. We found no difference. So you can't think about doing your own factory. Just find yourself a factory will make you empty plastic bottle with the name and everything, and just fill them with the county tap water. There's no difference. So the author agrees on that with us, what we have found. And a recent survey of bottled tap water in China found that this bottled China, 2/3 of those sampled bottles, plastic bottles, tested to have dangerous levels of pathogens and toxins. Pathogens means bacteria, fungi, viruses, and toxins means some chemicals, harmful chemicals. So some of those bottles, if you don't clean them very well, some of the bacteria, viruses will stick on this plastic. And some of the chemicals will be part of this plastic. So
So that is cut off on our slide.
What you say?
I said the bottom part is cut off on our slide. Hold on.
Yes, that's true.
If you go back, I'm saying
I drink most of the water, even with my wife. Oh. I told her to use the cup glasses, large glass, look like a wine glass, but a bigger, taller one. I don't use bottles. I use just tap water from the county, from the faucet. No bottles. But my wife goes to the Costco, whatever they call it there, and buy a bunch of those plastic. Said why? I said all her female friends, they don't drink anything from glass. They like it in bottles. Well, I said that's misleading, but she cannot convince them not to drink. Mm-hmm. So they have to have it in bottles. So but that's now that's no difference. Mm-hmm. As a matter of fact, the coming from the county is much safer because they have a lot of restrictions, a lot of treatment on it than the bottle. And I have a very ill or bad feeling about those manufacturing those tap water, bottle tap water. They might take it from the county without doing nothing to it and fill it and then sell it. That's just a bad feeling. I cannot verify this, but they can do it, correct? Who can unless there's some people work there and then verify this. Mm-hmm. Yeah, but anyway, sediment and heat also degrade tap water. That's always the case. The tap water will be degrade tap water. The heat is causing it to evaporate quickly than usual. So that's the reason whenever the source of rivers, you have to use the banks filled with a lot of type of weed or grass or plants that's resisting evaporation of tap water. So the tap water will stay there for a longer time. You cannot have rivers just they have no banks. You have these banks, and then you have to plant a lot of special trees that resist this evaporation and keeping this mild temperature around the river itself. Sediment is natural part of the river system. Sediment is fertilizes food plains and creates fertile deltas, but human activities, chiefly farming and urbanization, greatly increase sediment load in rivers. That's one of the other problem here. Thermal pollution, that's evaporating the tap water quickly, but as I said, you can get around this by planting a lot of good special plants that's really resisting this. So usually effluent from cooling system of power plants or other industries, whenever you have power plants, it has a lake, forget about any living creature who live inside this lake or pond. The tower coming out of this is very hot, 120 degrees, goes like steam there, boiling. So it will kill all marine life, all living creature inside. Even if the person is swimming there and you dump this from the cooling, this person will be really barbecued. It's very hot temperature coming out of this power plant and nuclear plants dumped inside those lakes. And then when it's cooled down, you dump again to be used for the purposes of whatever reaction they are doing. So it says the effluent from the cooling system of the power plants, nuclear plants, and they really changed the temperature of tower. Raising tower temperature from normal level can adversely affect water quality and aquatic life. You can't expect any lakes near electrical or nuclear plants will be dead. The temperature is very high. And they evaporate even the amount of tower there. Remaining problems. The greatest implements to achieving natural goals in tower quality in both United States and Canada are sediment, three ones here, sediment and nutrition. And those are the three major impediments or the problems you have. Problems in tower quality is the sediment, nutrition, and pathogens, correct? Pathogens, you have those bacteria, viruses, especially from non-point discharge of pollutants. As I said, non-point, that's very difficult, because you don't know the source of this contamination. But the open, or if you know the source, then you can put restriction and then you can find those industries. 3/4 of water pollution in the United States comes from soil erosion, fallout of air pollutants, and surface runoff from urban areas and from the farm fields and feedlots. So groundwater is especially hard to clean up. Well, can I clean up the contaminated aquifer? Yes, I can, but this is very expensive. You have to dump all the tap water contaminated out first. Take it to the treatment plant. You treat it for all the chemically and biologically, get all the viruses, bacteria out. This is one. Second, then you treat it by adding some oxidizer to kill to compose all the chemicals inside. Filter it. That takes us a lot of money. And then dump it back in the aquifer. You fresh and clean before that the tap or aquifer there. But then when you do this, you dump the whole thing. The cost of the tap water then at that area will be very high, because you have to compensate for this cost. You take the contaminated tap water from its original place, contaminated place, dump it out, treat it, and bring it back, and clean up the place and bring tap water back in. That costs a lot of money. That will cost a lot of money. And the tap water over there will be very expensive compared with non-contaminated tap water, ground tap water. The vital resource is threatened in many areas by overuse and pollution, and by a wide variety of industrial, agriculture, and domestic contaminants. EPA estimates that 1 trillion gallons of contaminated tap water seeps into the ground in the U.S. That's a lot. That's a lot. When deep underground aquifer are contaminated, it is possible, but very expensive, to pump tap water out of the aquifer, clean it, and then dump it back in. That will be very costly. and whoever lives in that area, those people will have to pay large amount of water bill and then all the other stuff. Related to the tap water, so it will be very expensive to do that. But it's doable, though. It's doable. Remember, the crude oil place is deep inside, compared with the tap water. Tap water in the top, the crude oil all the way back there. So you can clean the tap water, fresh tap water aquifer easier than you clean up the ground, the crude oil wells. They come underneath the tap water. So ocean pollution has few controls. Well, we talked about this, people. In the area near Kenya, Somalia, I think Eritrea, and in the east side of Africa, some I think Chinese companies, Korean companies are dumping a lot of waste, chemical waste, and people from Kenya and that area, they came one day and they saw. You can Google it, you can see the pictures there. There's a lot of dead fish. So then they altered the United Nations and they followed who had what. I think they are compensated for that. They are ordered to clean up the area. So, but the problem is it's very hard to clean up ocean. Why? Because the tap water is moving from one area to another area. It's not under our control. Correct? It's controlled by the wind. It's controlled by the surface air. It's controlled by the currents of the ocean themselves. So it's very hard. But if you have heavy ones, they are settling in the ground of the ocean. That's easy to scavenge them out. But the problem, if you have volatile ones, they can move all over the globe. You can have contamination in Kenya area. That will appear maybe in Japan. Are you following me here? So that's not, you cannot control it because too many factors are there, beyond our ability to get them out. So dead zones and poisonous algal blooms are increasingly widespread. Toxic chemicals, heavy metals, oil, sediment affect some of the most attractive and protective ocean regions. As I said, I gave you an example in Kenya area. That's and I think they found it. It's all Chinese and South Korean companies dumping some chemicals. They just came one day. A lot of the coast area all filled with dead fish. Anytime you see a dead fish, there is a contamination. That's what it says. Anytime dead fish, whether in lake, if you have even a private pond, and you see something dead there, fish is there, or dead creation there, or creatures, then something wrong with the pond. You might have to clean it up. Discarded plastic, flotsam and jetsam are becoming a mark of a human impact on the ocean. But I think this plastic now is going out. These plastic bags, they are affecting the marine life by suffocating them they can't get anything there because they are trapped inside this plastic bag. Dissolved oxygen will be depleted by the marine life trapped inside this bag. There's not enough oxygen. Those marine life like animals, they will be suffocated. We are having from the air the oxygen, they have it dissolved in H2O, but they are trapped inside this bag. They cannot get this oxygen replaced, so they suffocate. And that's what a major problem of these plastic bags, suffocation and trapping those animals. Those marine lives. So as you see, and that's not only those inside the marine life. The marine life has a lot of ducks, seabirds. Okay, so they are really affected by this. They are affected by this. So you'll see 6 million metric tons of plastics are tossed from ships every year into the ocean, where they ensure and choke seabirds, mammals, and even fish. Choke means the dissolved oxygen is not enough to be replaced, and therefore the animals or whatever, the fish, will die out. Water treatment and remediation, we talked about this. This is a very nice way to recycle our tap water. So whatever you take from the faucet, that's coming from the county treatment plant. Anytime you drink tap water from the faucet, think about this water is coming from, we are in DeKalb County, that's from the DeKalb County treatment plant. So, however, managing those tap water treatment plants, very expensive, because you are dealing with what? Biology and chemistry. You have viruses to fight, you have bacteria to fight, and the other part, you have chemicals to fight them. So therefore, it's very expensive, and that's the type of the pollution. But we have no other way to get around. We have to have a clean tap water, otherwise you cannot drink contaminated tap water. So that will cause a lot of death if you have to contaminate it, especially with some pesticides inside that causing a lot of cancer all over the place. So eliminating lead from gasoline, those are the measurements how we can make a remedy for this contamination inside tower. But as I said, those water plants is very crucial, but expensive to operate, and therefore they have to pay for it. I think every county has one, if I'm not wrong. So every county has one. So eliminating lead from gasoline has resulted in widespread and significant decrease in the amount of lead in the U.S. surface tap water. The industry can reduce the pollution by recycling or reclaiming materials that otherwise might be discarded in the waste stream. Using this approach, companies can extract valuable metals and chemicals and sell them back instead of releasing them to the environment, to the ponds, rivers, lakes, and ocean. So that's one of it, and that's a good thing. That's open point, open source point means those industries, so it's not difficult to deal with them. The problem of contamination of tap water is coming from sources you don't know from who are they dumping those stuff, this contamination inside the tap water, fresh tap water, in the ponds, rivers, lakes, and even oceans. So non-buoyant sources are often harder. That's what I said a couple minutes ago. It's very hard. The industries is straightforward because they have the procedure, they have all the directions, what to do with those contamination. Everything is there in detailed manner. But then the non-buoyant sources, you don't know from where it's coming. And that's what I said when we were in Decatur campus at that time, Cap College, then Perimeter College. Now Georgia said, I think they might have put some cameras there so they can find whoever is dumping some oil, some stuff there, old tires, some old papers, not used papers. So that's the major problem. If you don't know the source, then it will be very hard to deal with the contamination. So you have to do a lot of testing, a lot of work to determine what contamination you are dealing with. But if you know the industries, you know that factory has produced this amount of chemicals, of this type of chemicals. That much of contamination will come out. So all this, so it's very easy to talk to them in person. This is what happened, this is our finding, and so on. So the tremendous challenge of managing those non-buoyant sources, you don't know who they are, is seen as an example here in Chesapeake Bay. So that's another example. People dumping in that bay, nobody knows. But as I said, that was a long time ago. But now it's public lakes, rivers, and ponds. The public one. They have cameras. They have to. They have no other choice. Otherwise, there's a lot of contamination will be dumped. Anyone has no money to process this contaminated oil from the car oils. They will come and dump it inside the lakes and the ponds nearby. So, how we do treat municipal waste? I told you through the what? Through the municipal waste is treated through the county treatment plants, which is expensive, but we are in need of this, and it has multiple biological. You are dealing with viruses, bacteria, fungi, and chemical. You have pesticides, insecticides, lead, mercury, cadmium. All those chemicals, all those pollutants will be taken care in the tap water treatment plant. And municipal treatment, we have a couple minutes still. Municipal treatment has 3 levels of quality. Primary treatment, that's the big ones, the big waste, correct? So primary treatment physically separate big waste, large solids. Secondary, then you go the aerobic bacteria and fungi. Tertiary treatment remove the dissolved metals and nutrients, especially nitrates and phosphate. So you have three stages of get rid of the contamination. I will stop here, and I will see you next week to finish chapter 11 and go on.